Alright guys, so today we're looking at a coordinate geometry question. It will involve circles, which we learned about earlier in the year. The first part, however, is fairly simple. We've got 2 points, A and B, and we've got their coordinates here as -7, 3 and 5, 11. And we want a perpendicular bisector, and we've got to show that the perpendicular bisector is equal to this. So my first step would be, I'm going to do the gradient. And so the gradient of AB is the change in y, 11 minus 3 over the change in x, 5 minus 7, which gives us a total of 8 over 12. Or we could perhaps say, 4 goes into both of those, 2/3. Which means, therefore, that the gradient of the bisector must be the negative reciprocal, so will be negative 3/2. Now I'm going to find the midpoint. Because I need that for the perpendicular bisector, because a bisector runs through the middle of a line. So midpoint AB is equal to, and then I'm just going to have my add together my x values, divide them by 2, add together my y values, and also divide them by 2. And so in this case we have a midpoint of -1, comma 7. Therefore, the equation of my bisector will be as follows. I've got y minus y1 equals m into x minus x1, and I can chuck in some values to here. Y minus 7 equals my gradient, which I found is 3/2, into x minus 1, y minus 7 is equal to -3/2 x, and that would be -3/2, I think. And so y will be equal to -3/2 x minus 3/2 plus 7, and we can simplify that. Y equals -3 over 2 x, and that would be plus 11 over 2. So 11 there. Alright, now I'll just bring everything over here. I'm going to now multiply everything by 2. So I'll have 2y equals -3x plus 11. I bring my 3x over to join my y, and I have now demonstrated that the perpendicular bisector is equal to that. So I've done all the steps here. I'm good to go. Alright. Now, the next one, a circle passes through A and B. Those are the points that we had here at the top. And its center lies on this here. That's the center of the circle, lies on 12x minus 5y. And we've got to find the equation of the circle. Well, if you think about it, we also know that what I just found, the perpendicular bisector of A and B, this, that also, whoops, equals 11, not 1, that also is going to be give you a line that passes through the center of the circle, and here's why. Oh, let's not lose that. Okay, just imagine we've got a circle here. It's not very good, is it, really? That's even worse. That's not bad. Okay, so let's say we've got A here and B here. And if we join them up, we've got a line like this, right? Now, the perpendicular bisector of that line would be midway, and it would be perpendicular. And I think you can see that it's going to cross through the center of the circle. So the perpendicular bisector of 2 points, the line between 2 points, or a chord on a circle, will take you to the center of the circle. It will pass through the center of the circle. So we have, therefore, 2 lines passing through the center of the circle. So we could find out where those 2 lines are equal. So let's say that this one's a green one. This way. So where are they equal? And then we'll find the x and y coordinates of the center of the circle, which we need for the equation of the circle. Remember, the equation of the circle is such that, what is it? We'll have x minus a squared plus y minus b squared equals the radius squared. Okay, all right. So let's do this then. Okay, I've got 2 equations, this one and this one. First of all, I am going to multiply this equation by 4. So I will have 12x plus 8y equals 44. And the other equation is going to be 12x minus 5y is equal to 70. So I'm going to do EQ 2 minus 1. So this will give me, I'm going to do 1 minus 2. So this will give me 8 minus 5, which is 13y, and it'll be 70 minus 44, and that will give me 26. So y equals, hang on a second, have I done that right? Negative 26. So it'd be 44 minus 70, so it'll be negative 26. So this will give me y equals negative 2, and therefore by substituting x in, 3x plus 2 times negative 2 equals 11. So 3x equals, what do we say here? 3x plus 2y equals 11. Will be 15. So x will be 5. Okay. So we've got 2 of the components. We for the equation of the circle, we've got all of this bit now. We just need to find the radius, and we can do that by using the center that we've just found and one of the points that we already know. Now, if I go back up here, I know that A is, I'm going to use B, 5, 11. So I'm going to use B, this one here, B. B is 5, 11, and my my center is 5, negative 2. So I'm going to find the distance or the radius. So the radius will equal the square root of 5 minus 5 squared plus 11 minus minus 2 squared, just using Pythagoras here, and the radius will therefore be equal to the square root of 11 minus 2, 11 plus 2, that's 13 squared, which is 169, so the radius will be equal to 13. The last step is to write this in my circle equation. So x minus the value at the center, x minus 5, all squared, plus y minus, and my value for y is minus 2, minus 2, all squared, equals, and then I do my radius squared. And I can simplify this to x minus 5 squared plus y plus 2 squared equals 169. And that is it. We've done all we need to there. My suggestion is, if you're a little hazy on the old circles, is to go back to the handout that I gave you for this and review that. And then if you have any further questions, we can talk more about this in class. Alright, take care.